Hi, everyone. It's still morning, so good morning. I am excited to be here at jsday Verona. I'm sure you all are also excited to be here, so I hope that this talk that I'm going to be sharing would be interesting to you. Today, I'm going to be exploring how you can actually power up micro-frontends at the edge. If you're familiar with micro-frontends, hands. Okay, so it means that the first portion of this talk will be familiar to you already. My name is Gift Egwuenu. I am a developer advocate at Cloudflare. I'm also very active in the community. He mentioned YouTube, or I do a lot of other things, and that has helped me be nominated as a GitHub star and some other ambassador programs that I'm part of. Okay, let's take a look at this meme. It's quite popular, right? So I want everyone in this room to imagine they're that guy for a bit. And imagine you're chilling in a room, there is fire everywhere, and you're just relaxing, sipping your cup of tea or coffee, and you author the word, "This is fine," even though you know that, of course, you're in the midst of fire, right? This scenario here actually pictures, or it's quite similar to developers that are dealing with monolith applications. So you have developers that their day-to-day involves working in a massive scale application that is a monolith. And the downsides of that is that, of course, it's difficult to maintain, it's difficult to scale. And also, they are tasked with adding features to this application. Everything is a pain to work with, right? So when you're working with a monolith that is that large and you're still expected to make sure that it's as performant as possible and very fast, it's just not the best scenario. So instead of panicking, the developers are just there trying to continue working on the app while pretending everything is fine. Okay, that brings me to this exploration of the life cycle of monolith front-end. So I'll take you a bit back where we had just typical monolith application. But first, a monolith is an app that comprises of front-end, back-end, and probably the data storage all as a single unit, right? And then over time, people probably thought that it would be nice to just split up teams. So you have the front-end team and the back-end team. Of course, they still collaborate through stand-ups and all of that. And then microservices came. Microservices essentially means that the back-end portion of the code is split into several smaller services that work as functions. So you have, for example, an e-commerce application that has service for checkout, a service for payment. All of that is split into different services and have different teams working on it, right? That is great for the back-end. What about the front-end? All these services still consume one single front-end, leading to still having a problem in the front-end space because it's still a monolith app. And the front-end developers working there, of course, if you're dealing with a massive scale app that has a lot of dependencies, it's still not the best experience, right? So there are a few challenges with monolith front-ends. The first is that maintaining an application like that at that scale can become very slow, and also it's kind of leads to a very difficult user experience for the user, because if someone is trying to access an application that's large with probably slow internet, of course, it becomes slow. It's not like everybody here, I can definitely say, if you spend less than 3 seconds in an app or website, you're already moving on to the next website. People don't have patience anymore. So another challenge with monolith front ends is that with a large team working on a single unit monolith front-end application, the process of shipping code becomes very slow. It's very difficult for developers to maintain efficiency. It also causes technical debt. So you find that with applications like that, there is obviously going to be technical debt incurred. And then finally, the circle to shipping code is super long. I'm thinking of an app I'm going to be using an e-commerce example throughout this talk. An e-commerce app has several different dependencies from the carts, the payments gateway, and all of that. So if you have like a singular team working on all of this, it's just going to be very difficult to continue shipping code. So that's where the front-end community started advocating for micro-frontends. So essentially, piggybacking off what microservices is for the backend, we, as front-end developers, would also like to split up several parts of our application so that it's a bit easier to work with. So yeah, micro-frontends aim to break down a web application into smaller components that are independently deployed, and they can either use the same technology stack or separate technology stack. So you can have a micro frontend that's built with React, Quick, Svelte, depending on the choice of the team. And each of the micro frontend is actually a specific functionality of the app. So this is a separate architecture from the previous one that I shared. This, instead of what I shared, this is following something called a vertical architecture, where instead of having like a front-end team and then several different microservices, you now have teams split vertically, where one team is focused on maybe working on the payments gateway, where you have like a front-end, back-end, maybe a DevOps person as well. Their main goal is to ensure that the checkout process is working at every point in time. The same for the different vertical teams that I have listed on that image. Let's take a look at this example. This is a micro-frontends application in action. It's a single-page application, and it's composed of several different components. So you can see there, you can see a header component, a body component, a footer component, right? All of these are isolated applications that have been deployed, and you can access them independently. This approach, especially for larger teams, helps a lot with the team velocity. So you find that if you're in the front-end team and your core area is maybe dealing with the header, you're focused on that, the team starts shipping code faster, and the same applies for the rest of the micro front-end. Now, the app that I showed you, let's imagine it's just React, like everything is on the client side. But of course, when you're building micro front-ends on the client side, it's great, but it also has its own challenges. One of that is that it often requires that the browser would always download and execute multiple JavaScript bundles, also leading to slow performance for the app. It's very impossible to shake unused libraries when you're using shared libraries. So in that kind of architecture, you probably be using a monorepo, and you have like some libraries being shared from one micro front-end to another. And finally, it's also difficult to integrate server-side rendering when you're using, specifically, when you're shipping your micro front-ends on the client. So that's why this talk, I'm going to be sharing how you can actually build micro front-ends on the server side using Cloudflare Workers. If you're familiar with Cloudflare Workers, hands? Okay, great, okay. So essentially, Cloudflare Workers is a compute runtime or platform that allows you to ship JavaScript code to any of Cloudflare's global network. This is an example Cloudflare Workers script. What I have here is a JavaScript function, and I'm just returning like data about this conference. And once I deploy this, I have like a JavaScript functions that has been deployed to Cloudflare's over 270 points of presence. But yeah, let's take a look at our previous example that I shared. I want to take this app and now deploy it to Cloudflare Workers, so have it deployed on the server. What are the benefits of that? This is a cloud gallery app, and it's essentially very straightforward. I'll just go to the demo that I have, so it makes more sense. So this is the same app, right? It's a single page application, as you can see. But the interesting bit is this is actually a micro front-end that has different components built into it. So if I turn on this button called Show Sim, you would actually see it in action. So here I have 1, 2, 3, 4, 5. I have more than 6 components on this page that are independently deployed. You can already tell by maybe if I click on header. Header is like its own separate worker, a separate deployed micro front-end. And if I go back, oh, it's so difficult to to feel on my mouse. There you go. There you go. Okay, yeah. And so essentially this application is a combination of different micro-frontends pieced together. But how exactly does that work, right, on the backend? By the way, if you want to play with this demo, you can scan that QR code to get access to it to play as I am speaking about it. But yeah, how is all of this possible on the server side? Let's take a look at this architecture diagram here. Let's take a look at this architecture diagram. So essentially, the whole demo that I showed you is possible because of something called fragment architecture. So what we have there is we have a single page application. In this case, that's like the main application. And you have several different components of that from that application. Each of them is a single deployed worker. So it's like a JavaScript file, or in this case, behind the scenes, we're using Quick to build each of this worker. So each of them is a Cloudflare worker that has been deployed independently. The good thing here is once you run your worker, you can return a response. So all the response from all the child fragments are being streamed to the main fragment, which is the main single page application that you see that the browser finally ends up seeing. So in essence, what you get is you can actually go on to piece together different workers to make up your application. So in this case, the body app that you saw previously had two different components nested inside of it. Those are also two different applications that are managed independently. So essentially, this entire architecture uses something called fragments, where each worker is a fragment on its own that can be, you have like a parent fragment, you have a child fragment, you can piece together additional fragments on top of what you currently have, depending on your use case, right? This is the project structure of what I just showed you. So in the Cloudflare Worker application, you have the Cloud Gallery app. In essence, each of the components or fragments are actually Cloudflare Worker functions. You have like body, filter, footer, gallery, header, and the main app. But how do they actually work together? And like I mentioned, all of them are actually individual quick applications that has been deployed to Cloudflare Workers. But how do they communicate with each other? That is simply because of something called service bindings. So typically, if you're trying to build this without Cloudflare Workers, it might be difficult for you to maintain communications between these different components or different fragments. But because of something called service bindings, it's also possible for you to communicate between one worker to another. Service bindings are essentially configurations that you can add to your worker configuration file. On the side, this is the main app that I'm showing you now. And I want to make sure that the main app can actually stream response. The other fragments can actually stream responses back to the main app. So I defined like a service binding for each of the components that I have. So all of that is great. You've seen how you can actually go on to build micro-frontends from scratch. But what if you already have like an existing application and you want to incrementally adopt micro-frontends? That's also possible. We don't want to do a full application rewrite here, because that would take like months, in fact, sometimes years. So we want to incrementally add features to what we currently have. So I'll show you how that is also possible. So taking a look at the previous monolith front-end application that architecture that I showed you, you have like the microservices portion where each of the back-end logic is a service on its own, while the front-end essentially are pieced together. It's a single unit. But what if we want to, this is a legacy application, what if we want to incrementally adopt micro-frontends in this? So that changes to something like this. So we want to take like a functionality of this application and migrate it to use micro-frontends on the server. And for that, essentially, what you have is you still have your app, but on top of that, you can refactor, like, for example, the login components, have the front end, the back end, and the data all pieced together into like a team login in this case. And what you have now is a legacy application running alongside with a micro-frontend application. This is just the architecture. I can also show you how that is working with this demo. So if I go and play this might be very quick, like it's a second, but I want you to notice the difference between the left and the right. So I'm loading the one on the left is a legacy app. I'm going to play it again so you can see. The one on the left is a legacy app. You can see that it takes a bit of time for it to load. On the other side, you have the legacy app. On top of that, the login components pieced on top of the legacy app. And the resulting thing that you see here is, by default, the login component already loads because, of course, it's using Quick. Quick is super fast. It streams very minimal JavaScript to your application. So you see the difference between running your app using possibly if you're doing it only on the client side, and on the other side, incrementally adopting micro-frontends on top of what you have. Okay, let's go to the next slide. Yeah, all of that is possible because of something also called fragment piercing. So building upon the first thing I shared with you, fragment architecture, you can also incrementally adopt micro-frontends in your application because of fragment piercing. How does that work? So fragment piercing essentially combines the DOM element from a client-side, server-side rendered micro-frontend and piece that together with DOM element rendered from a legacy application. So in this case, this example here shows we have, at Cloudflare, we built a library called the piercing fragment host. This is what allows you to merge a legacy app and also a micro-frontend application. So this is how that is working. So I shared earlier an example diagram that looks similar to this. The difference here that you see is on the top side, you have the legacy application that is using React. And on the below that, you have different fragments that is actually deployed on Cloudflare Workers. The interesting bit is you can choose to deploy or use different frameworks that you would like to. At Cloudflare, we've tried this experimentation with Quick, React, and Solid.js. So it's possible for you to actually go on and incrementally adopt micro-frontends inside of your legacy application using either of these frameworks. So this is a demo I would like to also show you that is piecing everything together. Let me just go here. There you go. Oh my God. I can just do Control-2, right? Okay. Yeah, so this is a demo called Productivity Suite. Essentially, what it's doing is it's an underlying React application, and on top of that, it's piecing together different micro-frontend fragments. So here, I'm going to try to sign in. I can actually do the reloading and show you one of the benefits of using that. So the login fragment is deployed as a quick application. And if I try to log in, here we have different components that are deployed as singular fragments. So the first one there is sorry, my site is bad. The first one there is the list picker fragment. You have also the to-do fragment. Each of these fragments are actually deployed independently. And if I go to the next tab here, which is news, you also have some, a similar thing happening here where there is an existing or a different fragment, essentially, that is built using Solid.js. So all of this together, pieced together on top of a legacy application, is working so well, right? I want to show you something else. The great thing about this application is you can decide to take out any part of these fragments. Like I said, each of them are individually deployed workers. Going back to my slides, you can see here that I have the PS fragments on top of these legacy applications, they are logging to do to-do list and news fragments. Another interesting problem that we've uncovered is how difficult it is to address problems with shared global states when you're building with the client's context. By default, you would like to avoid something called fate sharing in complex front-end application. Essentially, fate sharing means that if one part of your application breaks, it can actually affect the entire application. So we've also gone ahead to do an experiment using something called reframing. So what reframing helps you do is it actually helps you load modules in your isolated context while giving you direct access to the DOM. So the first example that I have there is a monolithic application where it doesn't really have any shared library, so all of the context is alongside the app. The second example here is also using, it's using the, sorry, this is too small, I can't see. No, it's not zooming in. Okay, I'll just move closer. The second example there is also using the fragment architecture there. You see that the parent fragments and the child fragments are sharing their isolated context. Then what we're trying to solve here is to have each independent fragment have its own context, right? So how are we solving that? So we've created something called client-side context isolation that on top of your fragment piercing and the fragment architecture, you can actually have isolated context. So this same example that I have here, which is the login fragment, what exactly happens behind the scene is we're not essentially loading the application, we're loading it on top of an iframe. The benefit of loading it on top of an iframe is that you have like full layout and positioning fidelity for your UI. Oh, I'm going to go to the demo so I can show you. Yeah, so essentially the benefit of using client-side isolation on this application is that your application is loaded first on an iframe, and after a bit, the DOM actually clears that out so that your front-end application is loaded faster. To show you this in action, I will just inspect this element and try to reload this page. So what you see first is that this first fragment that I'm showing here is actually loading in an iframe, but the moment you reload that page, the iframe gets deleted and the application is sent to the DOM. In essence, why would you actually be using this? It actually helps with loading your application faster. Overall, we've seen that these three different ways to adopt server-side micro-frontends on your application really helps with making your application faster, also incrementally helping you adopt micro-frontends on the edge. So what are some benefits of using micro-frontends at the edge? There you go. The first is it helps with encapsulation. So your fragments are entirely encapsulated, meaning that you can control them and make them available to other fragments if you would like to. Another important benefit is that you can develop fragments independently. So like I showed you an example where you have a single page application and then we have like a header fragment and that is actually deployed independently. Another important benefit of using micro-frontends on the edge is composability. So it allows you to compose your application together. You can actually compose different fragments depending on the use case that you're trying to build out. This really helps with larger application if they are looking to incrementally migrate to micro-frontends, this is a useful use case to use for them. One last benefit is something called eager interactivity that this also allows you to do. One of the demos that I shared where I was showing side by side a legacy app and one using micro-frontends, you can see that your application, the application that is already using fragments actually loads faster and is already interactive even before the rest of the application is visible. So yeah, those are different strategies you can use to actually start building micro-frontends on the server side. In order for me to make this talk, the team actually made a lot of useful demos and resources to put this work together. So if you'd like to learn more about the fragments, piercing, fragments, and client-side isolate, you can check out these links. Oh, I'll just leave it for a bit. Yeah, that's pretty much what I wanted to share. Thank you so much for joining me for my talk. Don't forget to leave feedback if you'd like to, and also if you have questions. I don't know if I have time for questions, but if you have questions, happy to take them. You can also get access to the slides by scanning the QR code. Thanks.
Thank you so much. Are there any questions in the room? Yeah, over there. I'll go to you.
Sorry, I didn't understand exactly how the different micro-frontend communicates with each other.
Okay. Yeah, so I said that they communicate with each other using something called service bindings. So with Cloudflare Workers, you have a configuration file in your application where you can set up different configuration. So the main app that I shared, which is the main fragment that is housing the individual fragments, is connecting to the different fragments using the service bindings in your configuration. So for example, I don't know if I can go back to that slide to share. Yeah, so the wrangler.toml file for the main parent application sets up different bindings. So we have one for the header components and one for the gallery, the filter, and all of that. So this is how the responses are streamed from the children fragments up to the parent one. Cloudflare offers something called the service binding API. I think under the hood, I would say yes. That's how they communicate to the main application. Yeah.
Any other questions? I have something. Oh, there, small.
And yes, I just wanted to ask if how this approach would work if, for example, you have two different micro application with their own routing. So if it would work, for example, if I want to have a main application, which is just the conjunction of two applications with their own routing, would it work? Would it be more difficult to implement?
I think under the hood, where I shared that these are separate different applications, they are actually using frameworks, to make them. I think that individually, for example, if you're using maybe Solid.js for the implementation of the fragments, it's possible to route between a Solid application to another Solid application. It will be interesting to find out if it's also possible to do the same from like Solid to maybe Quick, seeing that you're using like different frameworks in between. I think I'll take that one back to the team and ask. Oh, yeah. I said I would ask like if it's possible to take from a different framework to another framework. I can ask the engineers, yeah.
So I have a question myself. So what are the things I need to consider before going into like micro frontends? Are there any downsides?
I think the reason for you to consider to migrate your application has to do with first of all, the scale of the app, right? So if you're building a small application, maybe that's not the best use case for you at the moment. When you find that you have like a monolith front end that's essentially performance-wise, it's pretty slow, and the next possible phase would be to consider using micro-frontends. I think that it is always nice to consider the situation at hand first before deciding maybe this is the next approach for you to take. But also looking at the benefits that I shared, like encapsulation, composability, those might also like be possible reasons if you have like maybe a large team of front-end developers and you would like to separate the different parts of the application so that people are more focused on dealing with certain apps, then that would be a possible reason for you to adopt it.
Thanks.
Yeah.
Final question? Over here.
Thank you. Thank you for the talk. You mentioned that using client-side micro front-ends, it would be difficult to sort of tree shake or deduplicate code. How does that work with sort of microservice, micro front-ends? How does the deduplication work, and how does that make it easier?
With micro front-ends on the edge?
Essentially with this approach, how do we do code deduplication?
I think that interesting question. I think that the idea is when you have your application deployed to singular, like you have like separate workers that are distributed, they are not essentially sharing dependencies like you would have with like a client-side, front-end application. So at the end of the day, Cloudflare Workers is quite fast in terms of performance. Like when you have different fragments or different components that are shipped on the server side, streaming response back to your main application is quite faster. So I don't necessarily think that there is going to be problem. First of all, they are not really sharing dependencies in order for you to tree shake them.
Okay, thank you so much. It was wonderful.
Thank you.
Yeah.